All right, we are going to do a line integral. This is a work integral. It's a line integral in a vector field, and the vector field happens to be conservative. So we will use that to our advantage in this problem. So this is the problem. We're going to find this line integral. This is our alternate notation for a vector field line integral. We have the first component times the x prime and the second component times the y prime. We have our curve for the line integral. It's this half circle counterclockwise, upper half, circular radius 4. And we know that we could do this integral by parametrizing the circle, finding r prime, doing the dot product of f dot r prime, and then integrating. But this vector field is conservative. And how do we know that? Remember, we do the partial derivative of f of the y component of our vector field with respect to x. So that's this derivative with respect, or this function with respect to x is 2x, compared to the derivative of the first component with respect to y, which is also 2x. And so the difference of those two is 0. That means the curl of this vector field is 0. So the field is conservative. So we do have a conservative vector field. That's great. With a conservative vector field, we don't have to do the integration. We can use the fundamental theorem of line integrals instead. And to do that, we need our potential function. So the potential function, I believe this is the same function we did in our video example of how to find a potential function last week, but we have v sub x is 3 plus 2xy. We do an antiderivative in x, and we have 3x plus x squared y plus maybe some function of y. And we have v sub y is x squared minus 3y squared. And an antiderivative in y is going to look like yx squared minus y cubed plus some function of x. If we take these two versions of v, these are both v. I could have maybe written this is v equals, and this is v equals. So we have two different versions of this potential v. We just kind of meld them together, and we find that v must be x squared y. What else? We have a plus 3x and a minus y cubed. So we have our potential function, x squared y minus 3 or plus 3x minus y cubed. From the potential function, we can do the integral without actually doing any integration. So let's see that. Let me erase and make some board space for that, and then we'll do it. All right, here we are. This is our line integral, and we have found that the vector field is conservative, and we have found the potential function for the vector field. So the line integral is just going to be equal to the potential at the ending point minus the potential at the starting point. And that's all there is to it. If we have the potential, then we just have to evaluate the potential at these 2 points. This does come out to be 3 times negative 4 minus 3 times 4, which is negative 12 minus 12, so minus 24 is the value of this line integral.